Land, capital, labor, and the entrepreneur, the four economic resources. The definition and understanding of the study of economics revolves around the burden of scarcity. These economic resources of land, capital, labor, and the entrepreneur are scarce relative to human wants. Economics is all about doing the best with the least, how to maximize production using the least number of resources to satisfy the greatest number of human wants. This is the simple circular flow model. This model was presented earlier in the term, but we're going to revisit this model to emphasize a few key points related to our study of the demand for resources. In this model, there are two markets. The resource market, up top, the green rectangle, land, capital, labor, and the skills of the entrepreneur, and the product market, down bottom. Product market are simply goods and services available for consumers to purchase. There are two market participants. On the left-hand side, you have businesses, and on the right-hand side, you have households. Supply and demand, market forces determine price and equilibrium price and quantity in markets. In the resource market, businesses are the buyers, the demand side of the market. Households are the sellers, the supply side of the market. In the product market, the situation reverses. Businesses become the sellers of products and services. Households become the buyers. Let's discuss the importance of free market capitalism and private ownership of economic resources. In a system of free market capitalism, one of the principal economic ideas is households ultimately own the economic resources used as a means of production. So households own land, capital, the two property resources, and labor and the skills of the entrepreneur, the two human resources. Businesses look to acquire resources because they need resources to manufacture and produce goods and services. So let's follow the lines to make sense of our circular flow. In the resource market, households bring resources of land, capital, and labor to the market as sellers. The orange arrow from households to resources signifies this process. What do households receive for selling economic resources? Well, land receives rent. Capital receives interest income. Labor receives wages, and the entrepreneur, if successful, receives profit. For businesses, expenditures in the resource market are referred to as cost of production. Cost of production were covered in a previous chapter. Businesses make expenditures to acquire the resources necessary to produce goods and services. So we can follow the black arrow from businesses, expenditures, which are known as cost of production, which generate income for the owners of the economic resources. The inputs provided by households, the orange arrow from households to resources, resource market, becomes resources for businesses. Focusing our attention now on the product market, as stated earlier, the situation reverses. Businesses use the resources acquired in the product market to make goods and services available in businesses use the resources acquired in the resource market to make goods and services available in the product market. So if you follow the income arrow from resource market to households, households sell resources ultimately to have income for consumption expenditures in the product market. These consumption expenditures, the black arrow from households to product market, ultimately provide the revenue that businesses need to pay for resources. And households take home the goods and services that businesses made available in the product market. A couple key ideas here. First, something we're going to investigate in more detail throughout the chapter. A concept economists call derived demand. If you think about the demand for land, capital, labor, and the entrepreneur, one might falsely assume that because businesses are the buyers of the economic resources that it is the business demand for resources that ultimately determines how much of each of the four economic resources are demanded by businesses. However, this is incorrect because Adam Smith introduced an important principle of free market capitalism: consumer sovereignty. Consumers decide the number of goods and services they want to purchase based on the utility that each product and service provides. How useful is a good or service to households? So households, individuals who make expenditures in the product market, signal to businesses the number of resources necessary to produce the products and services that maximize households' utility, happiness, and satisfaction. That's what we mean by derived demand. If you think about the demand for resources in the resource market, it's ultimately determined not just by the demand that businesses make in this market for these resources, but how useful households believe the goods and services to be. Right? If a product becomes more popular or more useful, businesses will need to acquire more resources in the resource market to produce that product or service. Obviously, if a product or service falls out of favor, the demand for that resource will ultimately fall based on the market signals of consumer sovereignty. Another important idea associated with the circular flow model is incomes that households generate from selling resources in a resource market are not altogether equitable. If you think about which resources demand the highest pay, it's entertainers, it's CEOs, it's Wall Street bankers, it's athletes, right? So the purchasing power of households is ultimately determined by the quality and desirability of the resources they own, which leads to an interesting dilemma in economics. Because some resources are valued more than others, it generates income inequality. So if you think about the demand for resources and the level of inequality in the United States, it can ultimately be traced back to this idea of the derived demand for economic resources. Let's begin our study of resource pricing. Obviously, firms demand resources. Firms need land, capital, labor, and the entrepreneur to produce goods and services. These are necessary inputs. We will focus our economic investigation on labor. The tools and strategies employed in this chapter will help us determine the price of the labor resources. However, these strategies are equally applicable to the other resources. So although our focus will be on labor, and the economic strategies developed and examined in this chapter will solely focus on one of the four economic resources, the strategies are applicable to the other three economic resources. Now, resource prices are extremely important. On the previous slide, we talked about money income determination. In other words, how much consumption expenditure power does an individual or a household possess based on the resources they control and the demand for those resources in the resource market. Another important idea is this idea of productive efficiency, the idea that businesses are constantly looking to minimize cost of production. We also discuss resource allocation. In other words, how are land, capital, labor, and the entrepreneur distributed among the production of a whole litany of goods and services, and does that lead to efficiency? Now, of course, this generates policy issues, such as if income is not distributed in a fashion that we would say is fair and equitable, what role does government play in redistributing income? One quick idea or example, farm subsidies. Are farm subsidies necessary for agricultural industry to sustain a certain level of farm output for the good of the country? So obviously farm subsidies involve redistributing income through the method of taxation from one source of income to another type of production through subsidies. Obviously, that also brings up fairness and equity issues and the ultimate problem of regulation. How much or how little regulation is necessary to address tax issues and redistribution issues. As we begin our examination of resource demand, we're going to employ an assumption that all markets are competitive. Goods and resource markets are competitive. Previously in our economic study, we introduced the four market models of pure competition, monopolistic competition, oligopoly, and monopoly. As an introduction to resource demand and resource pricing, we're going to employ this assumption that all markets are competitive. Second bullet point up here, if we are attempting to derive the demand for a resource, we have to identify that the demand for a resource is a combination of two factors, productivity of the resource and price of the good the resource helps to produce. Therefore, we call resource demand what is known as derived demand. It's derived demand because it depends on both the productivity of the resource and the price of the good it helps to produce. Let's examine the first one and then we'll discuss the price of the good. Productivity of a resource. In the previous chapter on the theory of the firm, the concept of marginal product was introduced. Marginal product is the change in total product associated with adding the next unit of a variable inputs. We examined marginal product in relation to labor, the change in total product associated with hiring the next worker. It's a measure of efficiency. We discussed the important idea of the law of diminishing returns. As you add a variable input, labor, to our fixed resource, capital, the firm, the size of the factory, initially output increases at an increasing rate. Then the law of diminishing return sets in. Output continues to increase but at a decreasing rate, and beyond some point adding more workers would actually detract from total production. So productivity of a resource is a measure of efficiency, and it equates to our idea of marginal product. The price of the good or service the resource helps to produce is simple. In other words, after the product or service is produced, what does the firm expect to sell? At what price does the firm expect to sell that product or service? So when we're trying to determine the demand for a resource, remember, derived demand. The demand for a resource is dependent on the productivity of the resource and the price of the good or service the resource helps to produce. Our last concept on this slide, marginal revenue product. I'm going to discuss this in more detail as we go through our resource allocation determination. Anything marginal is always going to be change. So marginal revenue product, change in total revenue resulting from change in resource, unit change in a resource. So quick review, total revenue, price of the good or service produced times quantity. That's how total revenue is determined for the firm, right? Marginal revenue, change in total revenue associated with selling the next unit of output. Now we're examining these ideas from the standpoint of inputs, right? In other words, if we hire one more worker, our change in resource, unit of resource usage, how much will that next worker increase total revenue, change total revenue for the firm? How does the firm determine the quantity of a resource, quantity of input of any land, capital, labor, resource, which will maximize the firm's profits in the short run? The firm will employ the MRP equals MRC rule to determine what level of an input will maximize the firm's profits. Studying the four market models, pure competition, oligopoly, monopoly, and monopolistic competition, students were introduced to the MR equals MC rule. A firm determines quantity of output, which will maximize profits or minimize losses for the firm in the short run, by equating the marginal revenue, change in total revenue associated with selling the next unit of output, with marginal cost, change in total cost associated with producing the next unit of output. The MRP equals MRC rule, similar analysis of the firm, but from the standpoint of inputs. Marginal revenue product. How much additional revenue does the firm expect from hiring the next unit of input? In this case, we're going to simplify our analysis by saying the next variable unit of labor inputs. Marginal resource cost. What's going to be the increase in cost, change in cost associated with hiring that next worker? So the firm will follow this simple rule, MRP equals MRC. The firm will continue to hire the next unit of a variable input as long as the marginal revenue product associated with that resource equals the marginal resource cost. So we equate change in total revenue over the unit change in resource quantity, MRP, to MRC, change in total resource cost, over unit change in resource quantity. And this rule will be our guiding light to determine quantity of an input of a resource the firm should employ to maximize profits in the short run. The firm's marginal revenue product of a resource equates to the firm's resource demand schedule. In this case, the demand schedule for labor. Two important assumptions are employed in this demonstration, demonstrating why the firm's marginal resource product equates to the resource demand schedule. First, the firm is competing in a purely competitive industry. Notice column 4, the firm sells all of its output. The firm sells its product at the same price. The firm is a price taker. We're going to employ the same assumption when we examine the firm's hiring process. We're going to assume that the labor market is also competitive. The labor market is also competitive. Each firm desiring to hire labor hires labor at the same price. Students should be certain to identify what's being measured in each of our 6 columns. Column 1, units of resource, in this case labor, simply the number of people employed at the factory. The unit of resource, the number of workers hired by the firm. Column 2, total production. So let's discuss the relationship between column 1 and column 2. If this firm hires 2 workers, the firm will produce 13 units of output. Total product will be 13. The ever important marginal product, column 3. Remember, marginal product is a measure of productivity. Marginal product reflects the law of diminishing returns. As we add a variable input, labor, to our fixed resource capital, we would expect efficiency to increase initially, but beyond some level of input, the efficiency begins to drop, because what happens? We can't expect to continue to add workers to our factory and for output to increase ad nauseum infinitely, right? Law of diminishing returns. As we add a variable input to our fixed resource capital, initially output increases at an increasing rate, then it begins to increase at a decreasing rate, and if we continue to add a variable input to our factory, output would actually decline. Simple idea. The size of the firm is fixed. Right? Our machines and our factory floor become congested. Therefore, the law of diminishing returns exists from a microeconomics perspective. It's an unavoidable economic reality. So, marginal product. If the firm hires 2 workers, total production increases from 7 units of output to 13 units of output. Therefore, the marginal product associated with hiring the second worker is 6. Right? Let's skip over to column 5, total revenue. How does the firm determine total revenue? Price times quantity. Price is available in column 4. Remember, this firm is operating in a purely competitive industry. They're a price taker at $2. They will sell each unit of output at the same market price, $2. Column 4 times 2, column 2, total production, yields the firm's total revenue. Right? If this firm produces 18 units of output, they will generate total revenue of $36. Now let's focus on the all-important column 6, the reason for our investigation, marginal revenue product, and then explain why the firm's marginal revenue product is ultimately the firm's resource demand schedule. Take our marginal product column, column 3. Remember, marginal revenue product is derived demand. It involves 2 parts. First, the productivity of the resource in question, that's measured by marginal product, and the price of the product the resource is used to produce, column 4. So column 6, marginal revenue product, is calculated by taking the marginal product, the productivity of the resource, times the price of the product the resource is used to produce. That yields our marginal revenue product. Right? So 7 times 2, the marginal resource product of the first worker is 14. That is to say, the first worker increases revenue by $14. The second worker increases revenue by $12, and so on down the line. We can graph our marginal revenue product to demonstrate why this represents the firm's resource demand schedule. On the horizontal axis of our graph down bottom, our downward sloping green demand curve, we simply have the quantity of resource demanded. How many units of labor does the firm desire to hire? On the vertical axis, we're measuring the wage. In other words, what must the firm pay these workers? So if the wage rate, remember, that's a purely competitive market for labor. The firm pays the going rate. Purely competitive market, all firms pay the same rate for workers. So if the wage rate is $12 per hour, this firm will desire to hire 2 workers. Right? You see that point on the demand schedule. Now, if you get really technical, this demand schedule is off by a teeny bit. Right? Don't let that mess up your brain there. You look and say, wait, 12 and 2 don't perfectly line up. Right? I know that. Just let's assume they do, because that could frustrate students when you're looking at that. But if the price of labor is $12 per hour, the wage rate, this firm will hire 2 workers. Right? If the price of wages falls to $6, this firm would want to hire 5 workers. Our downward sloping demand curve, which was derived from the marginal revenue product, represents the firm's demand schedule for the labor resource. The demand schedule derived from the marginal revenue product also reinforces the MRC equals MRP rule. The wage rate measured on the vertical axis on this graph represents the marginal resource cost of hiring the next worker. Lower wage rates would incentivize the firm to hire more workers because it reduces the marginal resource cost of that worker, in relation to the marginal revenue product of the worker. Let's advance our discussion further to the determinants of resource demand. The idea or term determinants should be familiar to students from the study of markets. There were 5 non-price determinants of demand and 6 non-price determinants of supply. When analyzing markets, these demand shifters or supply shifters caused a change in equilibrium, and therefore price and quantity in the market to also change, a new equilibrium price and quantity. In a similar fashion, there will be determinants of resource demand. The first determinant of resource demand is the change in product demand. So if a product grows more popular, or there's an increase in the number of buyers, or there's a decrease in the price of a substitute, there will be an increase in the demand for a product. Let's use a real-world example. Assume that new homes become more popular. A rightward shift in the demand for new homes increases equilibrium price and equilibrium quantity in the market for new homes. This in turn will increase the demand for resources associated with the production of new homes, such as construction workers. The next factor we have to consider is productivity. Remember, productivity is a measure of input per units of output. The first factor underneath the change in productivity is the quantities of other resources. So the marginal productivity of any resource, it's going to vary with the quantities of other resources used with it. So for instance, the greater the amount of capital and land resource used with labor, the greater will be labor's marginal productivity, and therefore labor demand. Another factor affecting productivity will be technological advance. So any type of improvements, technological improvements, which increase the quality of other resources, such as capital, they're going to have the same effect on the demand for labor, right? That's generally the way it works. The better the quality of capital, the greater the productivity of labor used, and therefore the more demand for labor resources. The last one, as far as changes in productivity, will be quality of variable resources, or the quality of the variable resource. So improvements in the quality of a variable resource. So think about labor, right? In other words, if there's an increase in the marginal product of labor, there will be an increase in demand for that resource. So if adding an additional worker increases output by more than in the past, therefore the marginal product of that worker is higher, there's going to be an increase in demand for workers. So considering all these factors, it helps explain the disparity in wages between modern industrialized countries, Japan, Germany, France, the US, and developing nations, Angola, Ethiopia, Cambodia, right? Because in advanced countries, workers are generally better trained, had exposure to and the advantage of a better education, and may even be healthier, right, than in some of these countries, right? So in most in most industries, they work in larger and more efficient settings where capital is used more efficiently, and therefore the wages earned by these workers in modern industrialized countries is greater because they add more to total output. Another determinant of resource demand is the change in price of a substitute resource. Assume a firm is using a certain level of capital, machinery, equipment and a certain level of labor to produce desired level of output. Now assume that the price of capital, the machinery, drops relative to labor. So the price of labor remains the same and the price of capital has fallen. So machines are less expensive. The marginal resource cost of capital, machinery, has fallen. This will in turn incentivize the firm to increase its demand for machinery. So when you think about how this change in the price of machinery, capital, will affect labor, there are two forces working sort of tug of war when you talk about the demand for labor. First, a decline in the price of machinery and the price of capital will mean firms will decide to replace labor resource with capital input, substituting machines for workers. So the substitution effect decreases the demand for workers. Now, an interesting development is that adding more machines, efficient machines, to the factory, to the firm, allows the firm to increase output at a lower cost. The increase in output, in turn, actually increases the demand for labor. To determine the total or net effect of the decrease in the price of machinery on the demand for labor, the economist must consider the substitution effect and the output effect in totality. So simply put, if the substitution effect is greater than the output effect, meaning that the firm has decided that the significant decline in the price of machinery makes capital a far more attractive type of economic input resource, even though it increases output by a certain level, most likely labor demand will decline. If the output effect, the total increase in production associated with the less expensive machinery, outweighs the substitution effect, there may actually be an increase in the demand for labor. An interesting real-life example would be what happened in the steel industry. In steel, we would definitely identify the substitution effect outweighing the output effect, and therefore declining the demand for labor in the steel industry. If you look at a ton of steel and the relationship between capital and labor over a 30-year period, the number of workers needed to produce a ton of steel declined from somewhere near 20 down to somewhere near 4. So in essence, capital, machinery, has become so efficient it replaced labor, and the output effect did not come nearly enough, or not to grow nearly enough, to outweigh the substitution effect. The net effect is a significant demand for labor in the steel industry. Recall our discussion of complementary goods and the demand for goods and services in relation to the price of complementary goods and services. One of the non-price determinants of demand is the price of related goods. Related goods are substitutes and complements, in this case complementary goods. The relationship between the price of smartphones and the demand for apps run on smartphones. A decline in the price of smartphones increases the demand for smartphones, also increases the demand for applications that run on smartphones. So we can take this economic knowledge about complementary goods and we can extrapolate it to complementary resources. In other words, what happens in the demand for resource A if there's a decline in the price of resource B, assuming that resource A and resource B are complements. Let's discuss real-world example of computers and computer programmers. The exponential explosion of computerization across the globe over the past 25/30 years has seriously increased the need for computer programming. Technological advancements have significantly declined the price of the PC. So a decline in the price of personal computers has increased the demand for computer programmers. An important caveat about this relationship between complementary good, price of one resource relative to another good. Important to identify the machine must be operated by a person. So a decline in the price of the computer directly increases to the exact proportion the demand for labor, because each machine must be operated by a human being. Obviously, this would be a different case if these were self-operating or automatic computers which did program without the assistance of a person. Now, an extension of this analysis, first an increase in the demand for computer programming, a significant decline in the price of personal computers, increase in the demand for the labor resource computer software engineers. One of the further analysis we're going to discuss in this chapter is trends, occupational trends over the last 10, 20 years and future occupational trends. Think about the American firm measuring the marginal resource cost of hiring the next software engineer. The increase in the need for software engineers influenced many Americans to study software engineering and management information systems. Software engineers in America, as mentioned in the previous slide about the price of resources in modern industrialized nations, much more expensive than in, say, a country like India. So American firms have found it economically desirable to offshore these jobs from the United States to India. Stepping into the realm of practical, recent article from CNBC offered the top 10 jobs expected to grow the most in the next decade. All right, so solar photovoltaic installers, obviously we do with solar energy, wind turbine service technicians. So there is a move towards renewable energy, energy resource economics covered in a different video lecture, but significant decline in fossil fuel demand over the next 10 years. So we talk about, the demand for one resource relative to other resources, substituting renewable energies for fossil fuels will significantly increase the demand for these particular industries. Number 3 and number 4, definitely related to the demographic shift of the United States. Older population going to need more home health aides and more personal care assistance. Notice that a lot of these top 10 are in the healthcare industry. Number 5 is interesting, occupational therapy assistants. So this is an example of when you talk about sort of a substitute and the value of one resource relative to another resource. So you would pay an occupational therapist a higher salary than you would pay an occupational therapist assistant. So healthcare providers constantly looking for ways to reduce cost may hire one occupational therapist and several occupational therapist assistants to work under the one occupational therapist. Again, you talk about the relationship between one resource and another resource. In a healthcare setting, the doctor would write the orders, the occupational therapist would oversee the rehab department, and the occupational therapist assistants service the therapy needs. Right? Information security analysis. Again, physician assistants is again a big move here when you talk about the need for primary care and the in many ways interesting serious lack of or need for primary care physicians across the United States, physician assistants, not only in primary care, but in other forms of healthcare, including specialties, are becoming the cost-effective choice for healthcare providers. All right, statisticians, again, nurse practitioners and physician assistants, many ways similar. You can look in, take your own time to look up, the rules and regulations on what one can do and what can't do, and it actually varies by state. But again, a nurse practitioner in many ways supplements the services of a doctor or complements the services of a doctor. And then the last one, speech language pathologist, which is an interesting one. I actually, this has to do with communication and swallowing disorders in both children and adults. That was the one that I actually had to kind of cheat and look up and see exactly what a speech language pathologist does. So these are the occupational trends according to research done by CNBC for the next 10 years. In addition to the determinants of resource demand, economists consider elasticity of resource demand. What is demand? It is a schedule of the various amounts of a good or service or a resource buyers are willing and able to purchase, series of prices, specified amount of time, ceteris paribus, other things equal. There's an inverse relationship between price and quantity demanded. Price declines, there'll be an increase in quantity demanded. Price rises, there'll be a decrease in quantity demanded. Economists refer to this as the law of demand. However, economists are interested in measuring how responsive are buyers to change in price. How responsive are buyers to change in price? If price declines, will buyers purchase lots more or just little more? If price increases, will there be significantly less purchased or just slightly less purchased? This same idea of elasticity can be applied to resource demand. The formula for elasticity of demand is percentage change in quantity demanded divided by percentage change in price. The formula for elasticity of resource demand is percentage change in resource quantity over percentage change in resource price. This formula will yield an outcome, a mathematical number. Interpreting the number is straightforward. If the elasticity of resource demand is greater than 1, economists refer to the elasticity of resource demand for that particular resource to be relatively elastic. That is to say, firms, producers, the buyers of the resource are quite responsive to the change in the price of that resource. Any outcome less than 1, so if the coefficient of elasticity of resource demand is calculated to be something less than 1, economists interpret that result as inelastic. That producers, the firm, is not all that responsive to the change in price of this particular resource. Economists consider 3 factors, identify 3 characteristics which highly influence the elasticity of resource demand. The first is the ease of resource substitutability. How easy is it for the firm to substitute one resource with another resource? The typical investigation involves replacing labor with capital. How easy is it for the firm to replace workers with machines? If it is relatively easy for the firm to replace labor with capital, to replace workers with machines, economists expect the elasticity of resource demand for labor, the elasticity of labor resource demand to be highly elastic, that is to say, responsive to changes in resource price. In this case, changes in prices of wages. So if the price of wages increases, we would expect a significant decline in the demand for a labor resource and look for firms to replace labor with machines. The fast food industry provides a real-life application of this scenario. Currently, fast food industry is dominated by low-cost labor. Many workers in these low-skilled jobs include teenagers and young people earning at or slightly above the minimum wage. If the government were to force the hand of producers, McDonald's, Burger King, Wendy's, Chick-fil-A, Sonic, Taco Bell, fast food producers, if the state government or federal government or some combination of the two raises minimum wage, fast food producers will look to replace higher cost laborers with machinery. Change from labor to technologically advanced machinery. The second factor is elasticity of product demand. This one should be relatively straightforward to understand. If the demand for a product or service is relatively elastic, that is to say, consumers are relatively responsive to changes in price, then the demand for the resources necessary to produce that good or service will also be relatively elastic. We expect elasticity of resource demand to be highly elastic if the demand for the product in question is highly elastic. The opposite would be the case if the demand were inelastic. The demand for gasoline is highly inelastic. There are no close substitutes for gasoline, and gasoline is a necessity. Therefore, we would expect, since the demand for gasoline is highly inelastic, we would expect the elasticity of resource demand for all resources necessary to produce gasoline to be also highly inelastic, aka oil. Significant price in oil is not going to alter the decision by gasoline producers to purchase this resource. Ratio of resource cost to total cost, our last factor to consider. The higher the ratio of the resource cost to the total cost, the more elastic is the resource demand for that particular resource. So when considering elasticity of resource demand, the higher the percentage that resource is to total cost of production, the greater the elasticity of resource demand for that resource. If labor is 50% of cost of production, we would expect that elasticity for the labor resource to be highly elastic, because changes in the price of the resource will be quite noticeable to the firm, as opposed to a resource which only represents 10% of the firm's total production. We would expect the elasticity of resource demand for that resource to be highly inelastic. Thus far, we have focused our attention on one input, labor. However, firms need to employ and hire all economic resources: land, capital, labor, and the entrepreneur. So how does the firm determine the optimal combination of resources? Right? How does the firm choose this optimal combination? Right? Well, the first assumption we must employ here is we are dealing the period known as the long run. In the long run, all resources are variable, including capital, the size of the firm. So assuming that all resources, all inputs are variable, it will help us determine the firm's optimal combination of resources. Now, the firm answers this question, what combination of land, capital, labor, and the entrepreneur best suits the efficiency needs of the firm, by answering two questions. First, what combination of resources will minimize cost of producing any given level of output the firm desires to produce? Right? And the second one is, what combination of resources maximizes profit? In regards to the first idea, the combination of resources, land, capital, and labor in the entrepreneur, that minimizes cost of production at any given level of output, students can refer to the cost of production chapter and the long run average total cost curve. The long run average total cost curve reflects graphically the combination of the combination of resources that will minimize the firm's cost of producing at any given level of output. How does the firm determine what combination of resources will minimize cost for any chosen level of output? So the firm wants to minimize the cost of producing a given level of output. The firm will employ the least cost rule. What does the least cost rule state? The last dollar spent on each resource must yield the same marginal product. So the firm is deciding what level of land, capital, and labor should be combined to minimize cost of production for a given or chosen level of output. For this example, we're going to examine the combination of labor resource and capital resource. The firm will identify the combination of labor resource and capital resource which minimizes cost of production for a certain given a level of output when these two ratios are exactly the same, equal. So the firm will measure the marginal product of labor versus the price of labor relative to the marginal product of capital over the price of capital. The mathematical example will reinforce the least cost rule. The least cost rule helps the firm determine what combination of resources will minimize total cost of the firm at a desired level of output. So the firm will spend the next dollar on the resource such that the dollar yields the same marginal product of other resources under consideration. In this example, the two resources are labor and capital. What combination of labor and capital inputs will minimize the firm's total cost at assuming that we want to produce 50 units of output? Notice the price of labor. The price of labor is $8 per unit of input. The price of capital, $12 per unit of input. Make certain you understand why these numbers are important. They will be respectively the denominators for the left and right side of our equation. So if you look at the left side of the equation, the marginal product of labor over the price of labor is $8. Right? Again, the price of capital is $12. So on the right side of our equation, price of capital, that will be our denominator. So make certain if you're asked to do one of these problems, you can easily figure out the left-hand side and right-hand side denominators by identifying what is the price of labor and what is the price of capital. We assume that labor and capital are hired in a competitive market, so the price remains the same at all units of inputs. Marginal product of labor is column 3. Marginal product of capital is column 3 prime. They will be our potential numerators for the left-hand side and right-hand side of our equation. We just need to find a scenario where the ratio is equal. That happens if the firm hires 3 units of labor and 2 units of capital. So notice the marginal product of the third unit of labor is 6. 6 over 8 equals 3/4. The marginal product of capital at 2 units of input is 9. 9 over 12 is also 3/4. So at that perfect combination, 3 units of labor input, 2 units of capital input, the ratio on the left is equal to the ratio on the right. So the last dollar spent hiring the labor resource yields the exact same marginal product as the last dollar spent on the capital resource. Let's make certain that this combination does indeed produce the desired level of output of 50, the firm's goal. If we look at total product, hiring 3 workers, 28. All right, looking at column 2. All right, 12, 22, 28. The third worker, 3 workers producing, total production of 3 laborers is 28. What's total product with 2 capital, right? 2 capital workers, 2 capitals employed, I should say. 22. 28 plus 22 does indeed add up to 50. So therefore, this firm will produce 50 units of output at a combination of 3 units of labor and 2 units of capital, minimizing cost. Take note, this combination of labor and capital is not the only combination which would produce 50 units of output. If you look at 5 units of labor, where 37 total products would be produced through labor, and 1 unit of capital, 13 output through the 1 unit of capital, that also equals 50. However, the combination of 5 labor and 1 capital does not fulfill our least cost rule. The ratio of inputs at that level would be unequal, and the firm would look for another combination to minimize total cost. Firms will also employ the profit maximization rule to determine the combination of inputs which will maximize profits at a certain given level of output. The firm must realize that the marginal revenue product of each resource must equal its resource price. What mix of inputs will maximize the firm's profit? What combination of resources should the firm choose to maximize profits? Earlier in this video, we introduced the idea of MRP, marginal revenue product, equaling MRC, marginal revenue cost. The idea is that the firm should continue to hire a resource as long as the marginal revenue product of that resource is greater than or equal to the marginal revenue cost of the resource. To determine which mix of resources will maximize the firm's profit, we simply apply the same approach to every resource under consideration. In this example, we have 2 resources to consider: labor and capital. The price of labor is $8 per unit. The price of capital is $12 per unit. It is assumed that these resources are hired in a competitive market, which means that every time the firm wants to hire another unit of labor, it does so at the market price of labor, $8 per unit of labor, $8 per worker. Same thing with capital. Every time the firm wants to employ another unit of capital, it costs $12 per unit. We're going to be evaluating column 5, the marginal revenue product of labor relative to the price of the labor, $8, and column 5 prime, the marginal revenue product of capital relative to the price of capital, $12. Should the firm hire the first worker? Yes, the marginal revenue product of the first worker is 24. Right? It only costs the firm $8 to hire this worker. As long as the marginal revenue product of that worker is greater than the labor price, the price paid for the input, it makes sense to hire this first worker. Therefore, it makes sense to hire the first worker, the second worker, the third worker, the fourth worker, and the fifth worker. Notice that the fifth worker, the marginal revenue product, 8 equals the marginal revenue price, 8, right? So the marginal revenue product of the fifth worker is $8. The marginal revenue cost of the fifth worker is $8. We've satisfied our economic rule: hire the input to the point where marginal revenue product equals marginal revenue cost. This firm should stop hiring labor at 5 units of labor input. Using similar logic, we evaluate the marginal revenue product of capital relative to the price of capital. The marginal revenue product of the first unit of capital is 26. Hire the first unit of capital, employ the first unit of capital, and the second unit of capital, 18 versus 12, and the third unit of capital. The marginal revenue product of the third unit of capital is $12. The marginal revenue price is $12. 12 over 12 equals 1. Notice this satisfies our profit maximization equation that is listed below our table here. The marginal revenue product of labor equals the price of labor equals the marginal revenue product of capital over the price of capital. They're both equal to 1. Right, so MRPs of labor and capital equal to their prices. So we have determined that CM should employ 5 units of labor and 3 units of capital. Now that we have determined the mix of inputs, factors of production, resources that this firm should hire, what will be the firm's profit? Well, we have to calculate total cost and total revenue for the firm, and then look at the difference between total revenue and total cost to determine profit. So if the firm hires 5 units of labor, its total labor cost will be 40. Right? Each worker receives 8, you hire 5 times 8, 40. Total capital cost will be 36. The firm is employing 3 units of capital at $12 each, 36. Total cost then for the firm is labor cost plus capital cost, $76. It is given in the problem that the product price is $2. So that's not on the table here, but it was given in the textbook. The product price is $2. This firm can sell as much or as little at $2 per unit of output as they desire. Right? So price times quantity equals total revenue. How do we know that the firm should produce 65 total output? All right, so we look and say, all right, at 5 units of labor inputs, what's total product for the firm? Just on the left-hand side with this resource. Well, at the 5th unit of labor input, total product is 37. Right? Similar analysis. How many units of output is produced by capital? Okay, well, the firm's going to hire 3 units of capital. Total product at 3 units of capital is 28. So therefore we add the 37 units of total product contributed from labor plus the 28 units of total product contributed by capital. That gets us to 65. Therefore the firm's total revenue is 65 quantity times $2 price, 130. Taking 130 of total revenue, subtracting total cost, this firm is generating an economic profit of $54. Our study of the demand for resources and resource pricing, the economic analysis that the firm uses to determine what combination of inputs, which mix of land, capital, and labor will minimize cost of production at a given level of output, and what combination of economic resources will maximize profits based on marginal revenue product and marginal resource cost, ultimately have huge implications on income distribution on a macro scale in the economy, and therefore harken back to the entire study of economics. Remember, economics is a social science studying the activities of human beings in the everyday business of life. Economists are advocates of the marginal productive theory of income. Simplest put, to each according to what he or she creates. According to this theory, right, resources receive pay according to the value of the service. So if you think about the connection between products produced and the inputs necessary to produce those products, workers and resource owners receive income relative to the value of the labor input necessary to produce a certain product and the value of the resources such as capital that are needed to provide goods and services. Owners of these resources are compensated based on their contributions to economic output. In theory, this sounds fair and just. The more a resource contributes to production, the higher it is compensated, assuming that in society, citizens purchase goods and services based on the utility. This sounds like a fair and just system for income distribution. However, it does lead to some inequality questions about fairness and economic justice. In theory, it sounds just and fair to compensate economic resources based on their contribution to total production. In many ways, it aligns with the economic theories of incentives matter, incentivizing laborers to work hard, to innovate, to be creative, to seek out new methods of production, to incentivize entrepreneurs to take risks and invest in capital, ownership of resources, such as to increase the total productivity of the country. Sounds as if it will achieve productive and allocative efficiency for society, and it aligns with many of the ideas of a free market. However, there are some serious criticisms of this theory. First, it assumes that economic resources are distributed equally at the beginning of, let's call it, the economic game. We can easily agree that within individuals, talent, creativity, industriousness, it's simply not distributed equally. Additionally, when you consider land resources and capital resources, many of the owners of these resources were not compensated with these resources through innovation, creativity, or hard work. They simply inherited these resources and had an economic advantage above others before they even started playing the game. So that's one of the criticisms when we talk about productive resources unequally distributed. Another issue is market imperfections. Market imperfections such that monopsony. A monopsony refers to a situation in which one buyer has significant control over the market. Consider Walmart, the United States' largest employer. Because they're such a large buyer in the market for labor, they may have significant control over the price of labor. Other factors of market imperfections. One is unionized work situations. Evaluate the salary of a unionized teacher versus a teacher working at a private school, doing basically the same job. The unionized teacher salary is twice as large with a nice host of unpaid benefits and a secured pension. None of those fringe benefits are in place for the non-unionized private school teacher, and there is no pension. Same thing with a union carpenter versus a private company carpenter. Right? The union carpenter may even be protected by the union for work that we would say is less than perfect or less than competent. Through the free market, through the marginal productivity of income distribution, determine how resources are compensated, or should the government regulate and redistribute? This is the ultimate question of this economic analysis and the last idea debated in this video. Obviously, this is not a simple question to answer. The more regulation, the less innovation. The more you stifle creativity, the slower the economy grows. However, income inequality has become a tremendous talking point among politicians and economists over the past 3 decades. Is it the government's job to regulate the monopsony who may have significant control over the price of labor in the low to middle income labor market? Should the government take measures such as inheritance tax on certain ownership of land and capital resources to achieve a more level playing field for the next generation? Do we need to tax certain incomes which may be compensated above and beyond what we believe is market fairness? Just some ideas to ponder. Thanks again for taking the time to watch this video. See you in future videos.